Hello, welcome to this video that goes through some momentum worksheet questions. Question 1, particle P of mass 2 kilograms is moving on a smooth horizontal plane with speed 4 meters per second. Collides with a second particle Q of mass 1 kilogram, which is at rest. After the collision, P has a speed of 2 meters per second and continues to move in the same direction. Find the speed of Q after the collision. So for this situation, we have particle P, which is mass is equal to 2 kilograms and is moving with a velocity equal to 4 meters per second, and it collides with a second particle which is mass is equal to 1 kilogram, and initially it's at rest. So we draw our situation before and we find what the total momentum is. So the momentum before is equal to the momentum of the first one, which is mv, plus so momentum 1, or momentum of p, mass of p and velocity of p, plus the mass of q and the velocity of q. So remember, this is p, this is q. From here we're going to plug in the value, so it's going to be 2 times 4 plus 0 times 1, which is equal to 8 kilograms per meter squared. So then we look at after the collision. So after the collision we have a ball. So after collision, P has a speed of 2 meters per second. So again, the mass stays the same and the velocity is now 2 meters per second going in this direction, and we've got Q where the mass is equal to 1 kilogram and the velocity is equal to VQ. So we know that the momentum before has to equal the momentum afterwards, so the momentum is equal to 8. And we know that that is equal to the mass of P after times the velocity of P after plus the mass of Q after times the velocity of Q after. So plugging in our known values is 8 equals 2 times 2 plus 1 times VQ. So 8 is equal to 4 plus VQ. So therefore VQ is equal to 4 meters per second, and that gives your answer for question 1. Question 2, a railway truck of mass 25 tons moving at 4 meters per second collides with a stationary truck of mass 20 tons. As a result of the collision, the trucks couple together. Find the common speed of the trucks after the collision. So if we look at the situation beforehand, we have a truck. So again, we'll just model that as a particle. So mass is equal to 25 tons. So that's 25 times 10 to the 3 kilograms. Remember, 1,000 kilograms is equal to 1 ton. And this is moving at 4 meters per second in this direction. So we'll call this A. And then collides with a stationary truck. So this is B. And this has a mass of 20 tons. So 20 times 10 to the 3 kilograms. And the velocity is equal to, or the initial speed we should say, is equal to 0 because it's stationary. So the momentum before is equal to the mass of A plus the initial the velocity of A, and then plus the mass of B plus the initial one of B. So we plug the numbers in. That's going to be 25 times 10 to the 3 times 4 plus 20 times 10 to the 3 times 0. So we just plug this into the calculator. We find that the momentum before is equal to 100,000, or 1 times 10 to the 5 kilograms per meter squared. Then it says, as a result of the collision, the trucks couple together and find the common speed of the trucks after the collision. So afterwards, the trucks are together as one object, so A and B. So their masses here is equal to 25 times 10 to the 3 plus 20 times 10 to the 3, and the velocity AB is equal to velocity AB, because that's what we're trying to find. We know that the momentum before equals the momentum afterwards, so that's equal to 1 times 10 to the 5. So 1 times 10 to the 5 is equal to the mass of AB times the velocity of AB. We put the equation of the mass in, so 25 times 10 to the 3 plus 20 times 10 to the 3 is 1 times 10 to the 5 equals 45 times 10 to the 3 velocity AB, and then we just rearrange our equation, so it's 1 times 10 to the 5 divided by 45 times 10 to the 3, and that gives us a final velocity equal to 20 over 9, which is equal to 2.22 meters per second. And that is your answer, well, velocity AB we should say. That is your answer for question 2. Question 3, particles A and B have mass 0.5 kilograms and 0.2 kilograms respectively. They are moving with speeds 5 meters per second and 2 meters per second respectively in the same direction along the same straight line on a smooth horizontal surface when they collide. After the collision, A continues to move in the same direction with speed 4 meters per second. Find the speed of B after the collision. So we start with our situation. So we've got A, A and B. So the mass of A is 0.5 kilograms, the mass of B is 0.2 kilograms. The initial velocity of A is 5 meters per second, and the initial velocity of B is equal to 2 meters per second. So we can find and they're moving in the same direction, so hence we can say they're going to the right. So we find the momentum before, which is equal to the mass of A, so that's 0.5 times the initial speed of A, which is 5, plus the mass of B, which is 0.2, times the mass of the initial speed of B, which is 2. Plugging this in, we're going to get 0.5 times 5, which is 2.5, plus 0.2 times 2, so we get a total momentum before equal to 2.9 meters per second. So we know that momentum before equals momentum afterwards, which is equal to 2.9 meters per second. So the next step we do is we look at this one. So after the collision, A continues to move in the same direction with speed 4 meters per second. So mass is equal to 0.5. The final speed of A is equal to 4, and then we want to find the speed of B. So B is equal to, mass is 0.2 kilograms. The velocity is equal to unknown. So we know that the momentum afterwards is equal to 2.9, and that's equal to the mass of A, 0.5, times the velocity of B, A, which is 4, and then that's just plus 0.2 times the velocity of B. From here, plug in the numbers, so 2.9 equals 2 plus 0.2 VB, and then we could just rearrange, so it's going to be 2.9 minus 2, which is 0.9, which is equal to 0.2 VB. Then we just do 0.9 divided by 0.2, which is equal to 4.5. So VB is equal to 4.5 meters per second. And that is your final answer to question 3. If you have any further questions, please let me know.